Our next presenter is Alin Vergatu with a sample lesson from the Large Assembly and Drawings workshop. Alin is an elite AE at Javelin Technologies. He's an avid contributor to the SOLIDWORKS community, and I'm sure some of you have seen him at the many presentations at SOLIDWORKS World. He is focused on problem hunting and designing tailored solutions specific to each company, customized to the individual end user.
Thank you very much for your introduction, Adriana. You are absolutely right. We are the world experts in working with SOLIDWORKS large assemblies and drawings. After all, we wrote the training course for large assemblies and drawings. We did that by partnering with hundreds of clients in the last few years to improve their assembly performance. And we collected everything we learned to create 3 very exciting products. The first one in this family is the large assembly performance audit. Imagine you have an assembly that gives you grief. You experience slowdowns. You can pack and go and send it to us. We will examine it and we'll provide you with an estimate about how much time you can save if you optimize it. And usually the time savings are impressive. You can go from twice as fast to maybe 10 times or even 15 times faster than what you are currently experiencing. The second member of this family is the Large Assembly and Drawing Workshop. This is a public course. You will join us for 4 sessions to learn how the software works under the hood, how to analyze an assembly, how to diagnose the problems, how to find solutions for the problems, and then how to encapsulate everything you learn into best practices. In this case, we will use our case studies. We will not use your specific assemblies. The next level, actually the next product, is the Large Assembly Productivity Service. If you have a team of more than 3 people who are experiencing slowdowns, it makes more sense to work with your own assembly. So we're going to offer this as a private service. We structure this in 3 phases. First, we're going to spend 1 or 2 sessions analyzing one of your assemblies. You choose the assembly and we work together to find out the causes for the slowdowns. In the second phase, we will design custom solutions to eliminate the slowdowns. We know every customer is different, so every solution is going to be tailored for your needs. And we're going to encapsulate everything we learn in these 2 phases to tailor a custom course for you to offer it to the whole team. So in a nutshell, this is what you get when you partner with Javelin. Now it is time for the fun part of this presentation. I'm going to give you a taste of the Large Assembly and Drawing Workshop. I chose 2 very exciting case studies from the mates lesson. Who doesn't like mates? In the grand scheme of things, if you're looking on the opening process for an assembly, calculating mates happens somewhere in the middle, so it can still drastically impact your performance, not only for opening, but also after the assembly gets open. When you're gonna take the training, we're gonna analyze in detail all the possible factors, diagnostic tools and solutions. We're gonna narrow it down to this phase, and we're gonna go through all the steps. I'm gonna scroll to these pages fast. We don't have the time for everything. And we're gonna take a look at a couple of important concepts. First of all the mates are being solved together. Imagine one big matrix that gets solved together. The other thing is that SOLIDWORKS is very forgiving compared to other CAD softwares. They allow you to add more mates than what you need, as long as they don't contradict each other. So how does SOLIDWORKS figure out which of those mates are actually required to fully define everything? It follows a parsing sequence. It's going to take a look at all the mates, it's going to identify things that are redundant, and it's going to ignore those mates. So this process can be time consuming. That's why it's a good idea to apply good best practices for applying mates. Once the mate matrix is identified, so we weed out everything that's not necessary, SOLIDWORKS is going to compute that mate matrix. The problem is if you have errors in the mate matrix, you're gonna have to wait, because SOLIDWORKS is gonna try all the possible pairings of the mates until it gives up and gives you the error. So this is exactly what this slide shows. Aren't you scared when you read the second statement? If no valid solution is found, this program will select the least bad solution. And now let's think about the consequence of that. In order to derive the least bad solution, SOLIDWORKS is gonna take a look at all possible mating schemes. So that is scary for me, can be extremely time consuming. Okay, so do not leave errors in the tree. Now, if you have overdefined mates, what are the tools that you can use for finding the problem? So let's quickly switch to SOLIDWORKS. I have here an assembly that have errors. The first thing that I will do, I'm gonna select the top name of the assembly. And you can see here you get a list of errors. The cool thing about this list is that all of them are links taking you directly to the mate that has a problem. So let me click on this perpendicular mate and you can see it takes me directly to that in the tree. So that's a good takeaway. Click on the top name, click on the error, it takes you there. The next thing you can consider doing is simply selecting the mate that gives you grief and using the isolate command. This is a small assembly. Imagine a big assembly, how useful this would be. It's going to hide any component that is not involved in this mate, right? So it's kind of easy now to take a look at this, maybe edit the mate and find out if these two faces should be perpendicular or parallel or what's going on there. Let's take a look at the third tool that you have available. This button at the bottom of the tree, I said button, but looks like just a red text, like an error. It is actually a button, you can click on it. So overdefine, once you click on it, it actually isolates only the components that have errors in here. It's gonna hide anything else. You can also click on some of the mates that have errors. Actually, you can click on all of them if you want. And SOLIDWORKS is gonna reveal these flags that also come together with action items. You can right click, you can press any of these buttons to do more stuff. So far 3 things: click on the top name, isolate the components that are involved in a mate, and use the overdefine button to see the mate error. The next tool that I'm very excited about is the MateXpert. You can find it by right clicking on the mate folder and you're gonna find the command MateXpert. This is great when you have multiple problems. So imagine you might have 3 mates that are conflicting on one side of your assembly and another 5 mates in a different side. So this is going to allow you to separate the problems. Right now I have 2 mates that are not satisfied. Those are the ones with a red error and a bunch of them that are having warnings. Let's press the diagnose button. So SOLIDWORKS is going to take a look at the mate scheme and it's going to find out that there are subsets of mates that are conflicting each other. For example, the perpendicular mate here is conflicting this concentric mate. If I delete one of them or if I modify one of them, these 2 are going to become happier. Here there is another subset of 3 mates, right? So this is a nice way to divide and conquer, to find out which mates are really conflicting to each other. The other thing that you can have here is the ability to hide the subsets, right? So for example, when I hide this, the components that are part of those subsets will be hidden, so you can focus on the ones that are important to you. The next tool that I would use is the ability to group the mates by status. Notice here I have quite a lot of mates. It's kind of hard to figure out which ones are good, which ones are not. What if I simply right click on the mates folder and I go to group mates by status? As you can see, I have 28 that are solved. I have 19 that are overdefined. Let me do a rebuild, Control Q, and you can see now I have the overdefined 17 in their own folders and errors. There are 2 there. Pretty nice. Let's try to fix the problem. So let's isolate the components that are involved in this mate and maybe edit the mate. Let's take a look what's going on there. So I have a perpendicular mate. Probably what I need is a coincident mate there, right? So makes sense. Get out of here. Notice how the number of overdefined mates went from 17 to only 12. So that mate itself impacted 4 others. Let's take a look at this concentric mate. Obviously, these two are not concentric. They shouldn't be concentric. Probably one thing I should do is I should simply suppress the mate and see what happens. So let's do just that and see if this is fixing the problem, right? So as you can see, it did fix the problem. So now you know a little bit more about the tools that you can use for fixing mates over definition. Let's go quickly through the takeaways. The top level assembly shortcut, you simply click on the top name, right click, and get a shortcut to the mates that have problems. Second thing, you can isolate mate components. You can right click on a mate, go to isolate, it's gonna show you only the components that are mated. MateXpert, very powerful tool. So go to the MateXpert. SolidWorks is gonna find subsets of mates that are contradicting each other. So it's allowing you to divide and conquer the problem. Grouping mates, very, very useful. You group them by status. You can quickly see which ones have errors, which ones are overdefined. Dynamic reference visualization is something that I haven't covered. I just want you to remember, if you right click on the top name, you can show dynamic reference visualization. Usually I'm using mates to point to their parents, and you can see when you click on a mate, you can find out the components that are being involved in that mate. Another possible factor of slowdown is the overuse of advanced mates, and usually it's the width mate or the symmetry mate that require a lot of computation. Well, guess what? We can go back to using primary planes because it's so much easier nowadays. Let's take a look at this part. So I'm going to use breadcrumbs to identify the fact there is a width mate in here, right? Allow me to suppress this mate. Now, notice this can move. The question is, how do I place this in the correct position in regards to this part? Well, wouldn't it be nice to reveal their primary planes if they were done properly? So how did we select primary planes in the past? Well, you'll click on something, you'll see what the part is, try to find where the plane is. Looks like we got it. Now you hold control so you don't lose that plane, click on another part just to see again where it is in the tree. You click again on the face with control to remove that face and find the other plane, and then you apply coincident. And I hope you agree that is madness. So many clicks, nobody's gonna do that. Well, the good news is that now in SolidWorks, if you have the planes visible as a category, you can select something and show its primary planes. So in this case, imagine that I don't have anything pre-selected. I'm gonna go here and select primary planes. That will reveal the primary planes of the main assembly. I click on it again, it hides the primary plane of the assembly. If I, for example, select these two components, so this one, and I click on this icon, I'm going to reveal the primary planes of those components, and then it's a simple selection and applying of a mate. Now, the cool thing about these primary planes, they can be found using keyboard shortcuts. So I can right click on any icon, go to customize, go to keyboard, look for primary, and I like to use the P for primary planes. So let's see how this works. I click on these two faces, I press P, I'm getting the primary planes. I press P again, they get hidden. The other thing that I like is the ability to add the primary planes to the context toolbar. So remember, you can click on a face, customize the toolbar, and then simply find the primary command and drag it over your toolbar. You can see it here. So how does this work now? I press on this, primary plane. Yep, press on this, primary plane. Cool, now let's select this plane and this plane. Let's apply coincident. There you go, everything is fine. Now let's hide those extra planes. So I don't know, I'm gonna select this, I'm gonna select that. Notice I selected actually two planes that belong to those parts. That allows me to click on the primary planes and the job is done. So pretty fantastic tool. It allows you to reuse something that people have been using for 20 years in a much more efficient manner. Next major factor of slowdown is the use of unoptimized flexible assemblies, who actually tell us very frequently that they are giving you grief. So what is the symptom? You try to drag something and you find out that it barely moves, or you might get all kind of errors in the mating scheme. What I have here is the same assembly inserted 5 times. All instances are flexible assemblies. Let's try to drag one of them. You can see this seems to move. Let me attempt this movement. Come on, come on, come on, come on. I'm dragging it. It doesn't actually move the way I want. It's actually lagging right now. SolidWorks was stopped for about 5 seconds trying to find a solution. Let's try this guy. You can see how hard it goes. To my surprise, there are just about a handful of mates, probably 2 handful of mates in the top level, so they shouldn't be too hard to compute. But if you dig a little bit deeper, if you use the performance evaluation tool, you're gonna find out that SolidWorks actually has 13 mates at the top level, that's true, but 243 mates get computed every time you drag anything. So let me open one of these sub-assemblies. I'm going to use the breadcrumbs for that. Let's take a look at what's inside here. So if I'm looking at the performance evaluation for this sub-assembly, I find out that it has 46 mates that have to be computed. So when you consider this a flexible assembly at the next level, those 46 mates have to be calculated at the higher level. 46 times 5 plus 13, you get that big number of mates. If you examine this a little bit more, you're going to find out that most of the mates are simply defining the position of one component in regards to another, especially 2 components that don't move in regards to each other. So those are not necessary at the top level, right? The only mates that I would probably need would be a concentric mate here, maybe something that's going to stop this from rotating, and if anything, a limit mate or a width mate from stopping from moving out of range. So how do you reduce the number of mates? There are 2 solutions. One is restructuring this assembly. So I'm going to create 2 sub-assemblies to capture the static mates, and I'm going to apply the dynamic mates only between those 2 sub-assemblies. I imagine the piston is going to be a good candidate for a sub-assembly. In this case, I have certain components that belong to the piston that are kind of hidden there, so I'm going to show you one of the tricks that I'm usually doing. I'm starting by saving a selection with whatever I can select with a box. Then maybe doing a section view. Let's do a quick section view through there, right? Let's click on this selection set to see what I already selected. I'm going to call hold control, and I'm going to select the other 2 components that should be added to this selection set. Now just be aware, if you selected the section faces, it will not actually select the components. So you might want to select existing faces of those components. Now with all the selections, the only thing I need to do is to right click on the screen and form a new sub-assembly. And you can see right now a new sub-assembly got formed. This is piston. Let's call it exactly that. So this is the piston. Everything else is going to be a secondary sub-assembly, which is going to be the body. So let's turn off the section view, maybe hide the piston for a second, select everything else, and form a brand new sub-assembly. When you do that, all the mates between all the components that you selected are going to be copied inside the new sub-assembly. There might be certain other mates that are going to be affected. So let's move those mates there. And you can see right now I have 2 components. One, let's call this body. The other one is the piston. And there are some mates that are being preserved by SolidWorks, whatever is being kept between them. I'm going to remake them myself. So allow me to delete all these mates. I don't need them. So this can move freely. This, I'm going to make it fixed. So let me make the main body fixed. This cannot go anywhere. Now, if I open one of these sub-assemblies, one thing you're going to find out, it has quite a lot of mates. It has 19 mates. The other one probably has, again, a lot of them. So all of those are not going to be computed at this level anymore, right? So if I'm looking right now, I have 0 mates that are computed at the top level. Let's quickly apply the mates that we want. I would like this face to be concentric to this face. If anything, I would like this to stop spinning like that. So let's take advantage of the tool that I showed you before. I'm going to make sure that the planes are visible. Let's find out the major planes for this subassembly and the major plane of the main assembly. So let me just simply press P. I'm showing you the main assembly. And maybe get the 2 top planes to be parallel to each other. Okay, now let's hide the planes, P again, they should be gone. So let's see, this cannot turn, but can still move in and out. I'm a big fan of using the width mate as a geometric limit mate. Kind of contradicting to what I said earlier, but in this case would be actually a great way of limiting the range. So let's select this face and this face and this face and this face and apply a width mate. Now, one cool thing about SOLIDWORKS 2020 and 2021, I can define this as a free width mate directly from the graphic area. So you can see it cannot move anywhere anymore. With these changes, let's go back to the main assembly and take a look at the result. So let's do a full rebuild. One thing that will happen, we restructured the assembly, some of the mates got lost. So actually this is a good opportunity to apply another best practice when using mates, which is avoiding the use of daisy chain type of mating schemes where one part is mating to the next and the next to the previous one and so on and so forth. As much as possible, you would like to mate everything directly to something that is fixed. Reduce the number of dependencies. So let's show the main planes of this assembly. I press P, you can see here top, right, and front. Let's select one of these subassemblies, press P again. So now I have the planes for these subassemblies. Well, the other thing that would make sense is to turn them to rigid for the mating process. So I'm simply gonna select all of them and make them rigid. Notice the moment I do that, SOLIDWORKS identifies them as being the same assembly, so it's gonna reveal all their mates. Before we apply new mates, let's delete the ones that we don't need. So we already know these are unnecessary, we're just gonna delete all of them. And let's start with the right plane of the assembly. I'm going to use that as the main reference for applying several mates. So I'm going to take advantage of the multi-mate button. So now let's zoom in a little bit. I'm going to select this plane. I'm going to select this plane. I'm going to select this one. I'm going to select this one. So the result is all of them are going to be mated to the main plane of the assembly. So instead of creating a daisy chain type of mating, I'm creating 4 mates that are going to be attached to one entity. You can also create a multi-mate folder. This is just helping you with how nice the feature manager is going to look like, the cluttering, also the ability to go and edit this again in bulk. Okay, let's do it again. And this time I'm going to apply a parallel mate in regards to the top plane of the main assembly. So again, I'm going to use the multi-mate button and I'm going to try to select all the planes of this assembly, of the subassembly, sorry. Right, so this one and this one. Same thing, I'm going to create a multi-mate folder, right? At this point, I don't want to see the planes anymore, so let me press P on this one, let me press P again, all the planes are gone. The last one, I'm simply going to use a little bit of a daisy chain in this case to apply the concentric mates between these faces. So that's going to be the only one when one subassembly is going to be dependent on the one before it. But the other ones, the other type of mates are much more robust, right? Because if I decide to delete one of the intermediary subassembly, let's say the second or third cylinder, the other mates are not going to fail. They're still going to be mated to the main components. Okay. Now let's take a look first of all of how many mates we're going to have if you turn this back to flexible. So let's select all of them, turn them to flexible, and take a look at the performance evaluation of this assembly. What do we have? Altogether, there are 32 mates that get computed. I'm wondering why. Let's do a rebuild and go again. Altogether, there are 32 top level mates. And remember, we started with 246. So that is a pretty impressive decrease. Now, notice when I drag things, this works so smooth compared to what I had before. It's easy for SOLIDWORKS to compute these mates. Let's go back to our presentation, and that was the main point. We reduce significantly the number of mates by grouping these components together in functional subassemblies. There is another way to achieve the same thing. One of my students asked me, what if you save this as a multi-body part? How do you do that? So let's reload this whole subassembly. Let's come up with another solution. So I'm going to open up again one of the subassemblies. And I'm going to ask SOLIDWORKS to simplify this subassembly by using the defeature tool. So let's start defeature. When I'm working with small subassembly, I use the option simplify. The other one is also the silhouette option. It's very powerful for large assemblies that we cover in another lesson. Let's go to the next step. First of all, do you want to remove anything? Would you like to remove maybe the internal components here? I can say yes if I really want to get rid of them. Let's say, yeah, you know what, let's get rid of these two components that are completely internal. Okay, we're gonna do that. Next, as you can see, SOLIDWORKS identified the components that are external. The nut and the gasket disappeared. Okay, what else do we want? Well, we'd like these guys to be one group. So I can actually turn off the section view just to make sure I'm selecting all the components that will belong to the piston, and they would become a separate multi-body part, a standalone multi-body part. Now let's select the other components and create another group. So you can see I have the two groups created. Now all the mates between them will be maintained. Let's go next. Remember, we just reloaded the file, so there are lots of mates that probably I couldn't care less. SOLIDWORKS will preserve the faces that are involved in those mates. Since I plan to remate this, I can clear this selection. Let's go next. Now it's going to simplify this to the max. Let's see the result. So notice this is the original assembly. On the right is a collection of two multi-body parts that are going to be assembled together. If you want to keep any of the little details, like in this case, maybe you would like to keep the socket, you have to select those faces. Otherwise, SOLIDWORKS is going to remove them. If I do a section view, you can also see that SOLIDWORKS removes the cavity. It also, let's turn off the section view. Notice it's going to merge bodies as much as possible. So maybe let's do another type of section view. You can see how these two separate parts are actually merged together. Even though there is a little gap between them, SOLIDWORKS is very efficient of filling those gaps. So the feature is unbelievable. Let's go next. And let's save this to a brand new document. You can even link it to the original if you want to. I'm just gonna save it for now. And let's open, or actually let's examine this new assembly that I just created. Right, so notice it contains two components. This is one multi-body part. This is the second multi-body part. If I wanted to preserve some mates before, I could. So what I'm going to do instead, I'm simply going to apply a concentric mate here. And I might want to apply, again, a mate that's going to stop this from spinning. So let's take advantage again of the primary planes. All right, so P to show this one, P to show the major planes of the top level assembly, apply another coincidency, and hide the planes. I hope I convinced you that using primary planes, it's actually very easy to do. Now, what is the advantage of using the feature in this case compared to the previous assembly? Why don't we make another assembly containing both components? Let me insert the main assembly. Right, so this is one. I'm gonna place it somewhere here, and also the one that has been the feature. So I'm gonna place it somewhere there. Now, if we take a look at how many graphic triangles, for example, are being used in both, let's use assembly visualization for that and go by the nested mode. Let's use the graphic triangles as a criterion, sorry. You can see I'm going from 30,000 triangles to only 10,000. So it's a pretty nice reduction in complexity. And also we reduce the mates to just 2, or if you want, I can add another one, and there are gonna be 3 mates there. I hope you appreciate the power of what I showed you today, the best practices, tools and techniques for working with mates. Of course, during the course, we will explore much more than that. Also want to show you a couple of deliverables of what you're gonna get. You're gonna get lots of articles, lots of best practices, but also the recording of the whole course. And we make it easy for you to find information. If you expand the description, you're gonna find out that everything is timestamped. So for example, if I want to go to flexible subassemblies, I press this button, it takes me there. And from here, the lesson starts. Moreover, the timeline itself can show you where you are. So right now we are in the flexible subassemblies. The next chapter is gonna be the feature, right? So it's very easy for you to know exactly how to find the information. I really hope you enjoyed this presentation, and I trust I'm gonna see you in our next large assembly and drawing workshop. Adriana, back to you.
Thank you, Alin. If large assemblies and drawings are a bottleneck in your productivity, there are plenty of solutions Javelin offers to speed up the functionalities, so I highly recommend you inquire further about those.